Hello students, on continuation of our electrical engineering drawing, in this class we are going to learn an interesting topic, that is how to draw lap winding. Before going to our main topic, let us recollect what we have seen previous class. In previous class we have seen that what do you mean by the conductor? What is the turn and loop? Let us, here you can see so this is the one armature you can observe in your laboratories. This armature consists of armature shaft and commutator and armature winding. So this winding we are going to learn in this class clearly. So armature winding is wound on a armature core. The core is laminated to reduce the eddy current losses. At the same time, the material generally used as a silicon steel to reduce the hysteresis losses. Now, if you are observing, this has the iron core, this is the core, and there is a slots here. You can observe it. In slots, we are going to insert our winding. Okay, you can observe here clearly. So, large size. Here this is a winding. So you can see this is one slot, this is another slot. In between there is a coil. What is the coil? Let us see clearly what we have discussed in previous class. Now you can see this is the one winding. So this 4-pole machine, the P is equal 4-pole machine. Okay, so in 4-pole machine here you can see this is a DC machine. This is a 1, this is a 2, 3 and 4, north pole, south pole, north pole and south pole. In this one armature is placed. Here we are connected the carbon brushes. From this one we are going to take it out. Okay, now our concentration is this armature only. So if you see clearly in this figure, 4-pole machine, if this armature, which is round shape, if I split it and make it so straight, I can see the number of slots in the core material. You can see these are the slots. You can observe these are the slots. I cut it here. I forcefully open this one with the flat. Then it is appearing as this is the slots in which I am going to insert my winding. Now you can see in this figure what is the coil. Coil is nothing but this is the one conductor. I can make this conductor some length, for example 1 meter length. This 1 meter length, it has some cross section area. For this length I can make it to the turn. Same length, but I make it. So this is the one conductor, this is another conductor, it's connected to the end. Here I can see this is the one turn. Single conductor for turn. Now suppose I require a large conductor. If I take it, make it number of turns is more. Here only one conductor, so I can take it here and it's going here and coming here and going here, coming here. So that means the current which is entered in the coil, so going and rotating after completion will come. Here whatever the current entered simply and come here. So here turn is a single conductor. Here so each coil side This is the coil side. This is the number of turns. Number of turns. So it's a single turn coil. This is a multi-turn coil. So each coil side has the more number of conductors for the more voltage inducing purpose. Okay. So multi-turn coil. So this is the coil. Coil is nothing but this is one turn. So turn consists of the two coil sides. And at the same time, the coil also having the two coil sides. Okay, so here you can see this is the conductor, this is one coil side, and this is the other coil side. At the same time, you can observe it. So here, this coil side is placed, for example, in Pakistan. At the same time, the other coil side should be placed in Bangladesh. So that means that one coil, this area should be one country, this area should be the another country. Our country is nothing but North Pole, is the other country is the South Pole. That is a coil pitch. Last class we have seen. Okay, so pole pitch, we can say the pole pitch. So pole, how we are going to get the pole pitch? So pole pitch is nothing but it's a 180 degrees electrical apart. Okay, so pole pitch is the number of conductors. How many conductors by number of poles we are going to get the pole pitch. Okay, so this conductor, it is going to pass slot under the north pole, and back side I am going to connect here. That is the back pitch. Already class we have seen. It is the distance covered by the back end of the connections. Okay, and it's coming to here. Now it is connected to the another conductor which is placed in nearby slot. So that will require the front pitch is required. It is the distance covered by the front from the end connections. Okay, it is the distance covered by the front end connections. So this is the back pitch, front pitch. Last class we have seen. So this is the number of turns. This is the coil. More number of conductors is the single turn. Okay, so here I am going to see that. Now for easy understanding purpose, you can see here. So here is I placed this is commutator segments. Okay, so here one coil I take in the two coils. This is one coil and this is another coil. So you can see that this is the red color, this is the green color, for example. Now it has the two coil sides here. This is the two coil sides. This is one and this is two. Similarly, it has also two coil sides. Okay, this 3 and this is 4 conductors. The coil 1 and coil 2. You can see. Now let us take the coil 1. So I placed the coil 1 in the first slot here, and based on the back pitch, last class we explained back pitch, and I am going to connect in the back side to the another country, that is under influence of South Pole. So this conductor is on the North Pole. Now that should be another end should be connected in South Pole. So it is connected here. So dotted means it is not appearing. So the solid lines is the directly appearing, and hidden lines is the bottom lines that's indicated here. Okay, so one pole which is connected here, and you can observe here. So this coil is connected to the second commutator segments. Over. Now let us take the another coil, second coil, and this coil is placed in the second slot, and with the same back pitch is connected to the adjacent to the other slot, and is connected to the third slot. Now the first coil and conductor and the second coil first conductor should connected here. That means here you can see, so from these two and this we can say this is a back pitch. Okay, now this two and this you can say this is a front pitch. Okay, now so this starting up first coil and starting up the second coil, we can say this is a resultant pitch. Why not? Okay, so this is basics we have seen last class. At the same time, in slots single layer and double layer, progressive and retrogressive already we have seen. Okay, multiplex, triplex and quadplex also we have seen. Now let us see in this class. So what are the different types of the armature windings? Let us see what are the different types of armatures here. So you can say these are the different of the armatures. Okay, so different of the armatures. So you can see this is the conductor length. Okay, so it is connected to the back, it is connected to the front here. Now you can see this is the length of the conductor. Here the conductor is more, and this is the conductor length is more as comparing to the this one. So here these are the number of slots, and similarly this one. So these all armatures are placed in the DC motors depend upon the different fields as per our requirement and applications. Each has a commutator. You can see this is the commutator segments, commutator segments, commutator segments, and this is the shaft over which we are going to place on the brushes, whether carbon brushes or copper brushes. Okay, these are the armatures. Now this armature winding. So what are the different of the windings? So here the armature windings are so mainly DC windings, DC motors, DC winding, and AC winding. AC winding. So now the DC winding is nearly a closed winding, the closed coil. Closed coil. That means if DC, if you are started leaving from your home at morning 8 o'clock, you are going to come at the same time evening 7 o'clock to your house. So from your house and to your house. It's a closed one. Whereas the AC winding, here the winding is not closed. Here leaving from home and going to your maybe your hostel, college hostel. Okay, so for a some 1 month, 2 month duration, there is no close between these two. Open winding, starting and ending, there is no physical connection between these two. Whereas every day here there is a ending and closing, a closed circuit. Okay, so let us see one example. You can see. You can see here one example. For example, here this is a winding, one winding, second winding, three winding, and fourth winding. Now this winding is connected to the here and is connected to here. Terminals. This is one winding, and this winding terminals and is connected to here and is connected to this. That means A, B, C, D. This coil 1, 2, 3, 4. Coil 1 and 3 connected in series, and A and B are the open. Okay, these are not connected open. So this is one slot, this is another slot, not same slot. There is no physical connection between the A and B. That is known as a open coil. Okay, so this is open coil. Now coming to the closed coil. What is a closed coil here? You can see closed coil. For example, you take the round shape, the armature, and here you can take the one coil, and this is 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 the one coil. Now here what will happen? It has a commutator segments. Okay, so this is connected in series, and this connected in series, this connected in series, and this connected in series, this connected in series, this connected in series, and it is connected to the ear. That means so all are connected in series. Whatever the coil ending, starting its and leaving ear also. This is known as a closed coil. So DC windings are closed coils, whereas AC is the open coils. Okay, so these are the types of armature windings. That are armature windings in a motors, whether DC motors and AC motors. There are the two types of windings: open coil winding and closed coil winding. What is an open coil and a closed coil? Now we have seen. Okay, now coming to the our interesting topic is the armature windings. So here you can see these windings, armature windings, maybe this winding may be different, this winding may be different, this winding may be different. How? So because this winding may be lap winding, this winding may be wave winding. So these are the different types of windings in DC machine. Okay, so let us see the what is the lap, what is the wave. Okay, so let us see that one also. Now this is the lap winding. Okay, this is the lap winding. What is a lap winding here? What is a lap? So here the conductor 1 is connected here, is going and back pitch is going here and coming here and is connected to the once come to the this back. So connected here and it's going here back pitch. This is the back side. Now if I am standing here, so my front pitch is this one, so back pitch is this one. Okay, so now I am the this is a, for example, this is a motor. If I see this is a motor. Okay, this is a motor and this is slots. Now if I am placing here, this is my front and what this is the back. Okay, suppose here I place it down my winding, the first slot here from this one, and is going to place another pole pitch here. This is one. So this under influence of this is known as the back pitch, you know, YB, and this is known as the next slot is the YF. Okay, now in this case what will happen? So the winding is going this one and coming once again back to this one and going back and coming to this one. So this is the lap, nothing but this is the lap. Simple. Have you remember? So our Hanuman tail also lap. You can see this. You can see. So how is our hero? So here our Hanuman sitting on a tail. Okay, without offering any chair, is made his own tail as a lap. You can see this one how he is connected. So his lap, okay, so made as a big chair. So this going down. So this is known as the lap winding. Okay, so don't bother about the students. I will explain and details later. Okay, so here this is the lap winding. Now what is the wave winding? So in wave winding, so lap winding, so these conductors, what are the conductors? Under influence of one pole pitch. So this conductor is connected here and is coming here and is connected here and going once again and is coming once again back, coming and going to back, just like so going this one. This type of the winding is known as the, okay, so here is connected to just like it's connected here, this one. Okay, so these are the starting and ending. Okay, this is known as the lap winding. And coming to the wave winding. What is a wave winding? So 1, 2, 3, 4. For example, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. For example, under influence of North Pole, South Pole, North Pole, South Pole. For 4-pole machine, P is equal 4-pole machine. Okay. Now, this is a conductor. First one, I connected to the one pole pitch in south. Next, instead of coming back, it is going to the another pole pitch. Now it is going to the another pole pitch. Now it is going to the EM. So that means it is going the wave. Okay, have you seen, observed in the sea, ocean waves? Now you can see this is the ocean waves. Okay, so this you can see this is the ocean wave. How the waves are going and it's coming. Okay, so these waves, just like waves, this is sea waves. Similarly, our winding also, so go on increasing this side or go on increasing this side and coming this one once again is coming to this one. Okay, so it is going on. Okay. So that is the wave winding. Okay, let us see the how the wave winding we can draw and how the lap winding we can draw. What are the basic principles? What is the back pitch and front pitch? We'll see later. Okay, so don't bother about them. At a glance you can see what is the difference between the slab winding. So here now you can see the dear students, now this is a lap winding. Okay, this is a lap winding, this is a lap winding, and this is a wave winding. Okay, so this can be preferred when the current value is more required. So I value is required, we can prefer with the lap winding. Whenever I require the voltage value is more, then I prefer for the wave winding. Okay, so at the same time it is the number of parallel paths. A is equal to P number of poles. Here you can see, for example, this is the one pole. Okay, this is another pole, this is another pole, this is another pole. The P is equal to 4 poles. Now parallel paths are also 4 poles. Okay, so whereas in this case, so number of parallel paths, A is equal constant 2 poles only. That means here, so 1, 2, 3, 4 parallel paths connected here. This is for example plus, this is a minus. Each path is generating some current. Each current is collected here. Okay, so this is current. The current is as per the Kirchhoff plus sum of the current entering here. This current, this current, this current, whatever the generated is given here. Or if the motor, whatever the current entered, the shade equally to the parallel paths. But in this case, what will happen? Only any number of poles, but is only 2 parallel paths only. So here, whatever the voltage generated is equal. So that's why, so it preferred for the higher voltages. It is preferred for the higher current. Okay. So these are the some relations already you have seen in theoretically. Okay, so our aim in drawing is how to draw this lap winding, how to draw in wave winding with a single layer or double layer. Okay, so let us see. Now you can observe here also. So same machine. So this armature, this is the armature commutator, this is armature. Now coils, you can see this one coil, the second coil is connected in different pole pitches. So you can see south pole and north pole under pole pitch. This is a back pitch, this is a front pitch is connected to the commutator segments. Now if you are taking this one, this is nothing but this commutator segments, and this slots is nothing but this machine. Now what will happen? So this each conductor is connected going to the back pitch and coming to the front pitch. It's kind of back pitch and front pitch is connected such a way that it's a lap winding. Okay. Whereas in the wave winding, you can see 2 coils are connected. One coil is connected in the between the one pole pitch, and at the same time another coil is connected to the another pole pitch. Just like you can see here, one commutator segment is connected to the here. This coil is connected here, one segment, and is connected to the another one. So this is a wave winding. Okay, now let us know about the lap winding. What are the salient points of the lap winding? Okay, so let us see what are the points we have to remember. Here, so mainly, so lap winding is nothing but it is just like it's a parallel winding. You can say lap winding, or we can say the parallel. So Hanuman tail parallel winding. Sometimes we can say. So in which the coil lap over each other. So just like it's over each other. So the ends of the coil come back to adjacent segments of the commutator. Okay, so the conductor of one coil starts from one slot under one pole and goes to the slot under adjacent pole and return to the slot under the first pole. This is the definition already you know. Okay, so each parallel path has equal voltages. So number of parallel paths is equal number of poles, and total current will be divided equally in each parallel path in case of the motors. Okay, so it is best suited by the high current purpose. Now, what are the salient points here? Remember to draw the winding. First, here, so first you have to find that how many number of slots. Find it slots or conductors. Find the conductors. Conductors generally represented by the jet. Slots are yes. Now, based on the number of conductors and number of poles, how many poles is given, how many number of conductors is given, sometimes how many coils may be given. Okay, so one coil is equal to 2 conductors, as you know that. Now, first point you have to remember that. So, here back pitch and front pitch must be odd. That should be in odd and opposite sign. Opposite sign. So, at the same time, the difference between YB and YF should be 2 or multiple of 2. That is the first point you have to remember. Multiple of 2. Back pitch and front pitch always odd and opposite sign, and a difference between 2 is 2 or multiple of 2. First point. Second point you have to remember that here the back pitch and front pitch approximately equal to the pole pitch. So pole pitch is the difference between the two consecutive poles. Okay. Now, at the same, the third point you have to remember that the average pitch. So Y average is equal to, so back pitch plus front pitch divided by 2. That is nothing but, so total number of conductors by total number of poles. That is nothing but pole pitch. Okay, pole pitch I have seen. That is the another point. Now, at the same time, fourth point you have to remember, at the same time commutator pitch. The commutator pitch is equal to plus or minus 1. If plus indicates the winding is progressive, that is going towards from left to right. Suppose if that is the minus, the winding is going and right to left. Progressive, retrogressive, already we have seen. Okay, at the same time, and you have to see the fifth point, remember, and the resultant pitch YR. YR is nothing but the difference between the two consecutive beginning of the two consecutive coils. Okay, so two consecutive coils. So if you are seeing this one, so this coil and this coil, the distance that is known as a coil YR. So that is, we can write it the back pitch minus front pitch. That is equal, what is the back pitch minus what is the front pitch. So we are going to get it, that is pitch. Okay, so in this case, the what is the progressive or retrogressive already we have seen. Here, if you observe, here if the YB is greater than the YF, that means, for example, YB is the odd number now. If we take the YB is equal to, YB is equal to 13, okay, and YF should be whether it is 13 plus 2 or 13 minus 2. Okay, so that is equal to 15 or it may be 11. If the YB, here condition YB is greater than the YF, that means these two cases. So 13 is greater than the 11, then the winding is a progressive winding. Okay, then commutator pitch is a plus 1, Y plus 1. If YB is less than YF, that means here 13 less than and 15, then the winding is a retrogressive. That is at that case the YC commutator switch is called minus 1. Okay, so these are the things you should remember. Okay, so how you are going to find the YB first of all? So here the back pitch. So what are the back pitch you are going to connect here, and what are the connect your front pitch? Okay, back and front. So here nothing but this is a back pitch YB you are going to calculate, and you are going to front pitch. How we are going to calculate that? So simply the YB is equal to total number of conductors by P plus 1. So back pitch you are going to get it. And Y front pitch, if you know the back pitch, difference by 2. But this is a progressive or retrogressive. The progressive, we can simply minus it. So that is equal, or we can write it Z by P minus 1. So these are the some salient points, dear students, to complete this thing. Okay, so we will take the one example problem. Okay, now so these are the one practical example. Okay, so if this is the um, our armature, this is a commutator, this is armature, and this is a fan purpose, this is a shaft. Okay, so these are the slots. You can see this is a slot 1, slot 2, slot 3. Similarly, if it is cutted this portion, one portion, make it straight. You can just like you can take this one. So this is the one lap winding. If you're observing from this side, if you're observing this side, so you're going to get it this one. Okay, for the two pole machine, this is a north pole, this is a south pole, and this winding is connected. End connections, you can see that this is one plower, just like the plower. End connections. Okay, so whatever this is the front connections, and this is the end connections. Okay, so now if I know how to where we are going to place this first slot, we take the any one slot as a first, and going to the another is the pole pitch. Then coming to the ear and coming to the, so similarly you are going to get is similar to this one. And as an electrical student, so you are going to draw this one. Okay, so with the help of the number of slots and back pitch, front pitch, and breast position, slots should be, you have to draw it. Okay, so we will take the one practical example, we will draw that one. Okay, so these are the some basic salient points before going to draw the figure. Okay, so dear students, let us conclude what we have seen in this class. So in this class we have seen that, so basic things of electrical windings. What is the conductor, what is the turn, what is the loop, what is the pole pitch, what is the back pitch, what is the front pitch. And pull pitch coil means equal to the back pitch, equal to the pole pitch. If less than that one, there's a chorded pitch or short pitched coils. And resultant pitch and single layer and double layer. So retrogressive, progressive winding we have seen. At the same time, what is a duplex winding, quadrexial. Last class we are given the example, and in this class we are given the types of armature windings. So that may be DC winding or AC winding. The AC winding is the open winding and DC winding is the closed coil winding, and how they are connected basically we have seen. At the same time, we have concentrated on the lap winding and wave winding, how the physically their windings, we taken the examples, and we have learned some salient points. Okay, now let us try to draw our one basic lap winding, single layer lap winding. Okay, so we will do in the next class. Thank you for listening my class, dear students.